A skill that you learned in grade 9 that you will be expected to be able to use in grade 10 and grade 11 and throughout your math career is graphing a linear function. Right? Most often we see linear functions in what we call y equals form, or also called slope y-intercept form, because in the form y equals mx plus b, you always have an m, which is a slope, and a b, which is a y-intercept, which makes it pretty easy to graph something like y equals 3x plus 2, or y equals negative 1/2 x minus 1. So in each of these cases, you'll want to recognize the slope. Here's the slope here. This first linear equation has a slope of 3 when we graph it. This one has a slope or a rate of change of minus 1 over 2. Now, you'll remember, of course, that slope is always rise over run. So in the first case, here we have a slope of 3, right? So if the slope, or m, equals 3, it might be more helpful to view that as a fraction, because we know that slope is kind of a fraction of rise and a run. So any whole number you could make into a fraction by putting it over 1, right? 3 over 1 is the same as 3. And so the rise in this one would be 3, and the run in this one would be 1. In the second case, if the slope is negative 1 over 2, we would look at that and we would say, well, I know that the slope of that one, m, must be negative 1 over 2. Now, I usually encourage students to recognize, first of all, that you know that a slope, when it's negative, you know that that line is going to do something go diagonally down to the right as you draw it. So first of all, good to know that. Second thing, I would encourage that if you have a slope with a negative, that you commit to putting the negative either on the top or the bottom of the fraction. I usually default to putting it on top, and therefore I know that the rise in this case is negative, which means that it's not actually a rise, that this thing will be going down. If I were to put the negative on the bottom, it would still work. I would have to know that a negative run would mean that it would be moving to the left instead of to the right, as it usually does. So for simplicity, I usually say, hey, if you've got a negative type of slope, just move that negative into the top of that fraction. It doesn't change what it is. Overall, it's a negative slope. Helps when you're drawing to include it in the numerator. So, since we know this slope, that's very helpful, but it's especially helpful if we know where we are starting from. So, in order to graph, for example, this first equation, we know that b means the y-intercept, so that means that the y-intercept that we're starting at for this case is 2, right? Here's the y-axis, the x-axis, and the y-intercept is the point on this line, right? We would say that it would have, another way we could say that it has a y-intercept at 0, 2, right? And this 2 and that 2 correspond. So we have our point, or our y-intercept here, and then we know that we have a slope of 3. We know that means a rise of 3 and a run of 1. So if you watch what I do here, a rise of 3 is 1, 2, 3, and a run of 1 means 1 to the right. And so I'm going to put a second point right where I ended up. 1, 2, 3 up and 1 to the right. I'm going to repeat that. 1, 2, 3 up and 1 to the right. And I'm even going to do a couple backwards. I'm going to go down 3, right? 1, 2, 3, and 1 to the left, right? And that would line right up with my other ones. And in doing this, I'm going to end up with a pretty nice set of points that are going to be the basis for my line. And then I take my ruler and I draw a nice straight line through the points. Now, when you draw a line for me in my class, I always want your line to extend all the way to the end of the grid. You put arrows where you know that line is going to continue, but I do not want a little section of a line. I want your line to go all the way to the end, all the way to the end with an arrow to show that it doesn't end there. I also want you always to be aware that even though there's some points that are on the line, there are plenty of there's actually an infinite number of points, not perfect ones, not beautiful ones, right? These are nice, beautiful, whole number of points, but there's a whole infinite number of points that this line is actually made of. Let's take a look at the second line. The second line has a slope of -1/2. So we looked at that and we said, well, that's a rise of -1, which means actually it's a fall of 1 and a run of 2. This -1 means my y-intercept is here at -1. And from there, I'm going to fall 1 or rise 1 and run 2. And I'm going to do that again, fall 1 and 2. So I'll put some points where that ended up. Here and here, and again I'm going to repeat a few, maybe even backwards. I'm all about getting a nice accurate good line. Use my ruler and I draw in that line. So graphing a line from y equals form or from slope y-intercept form is no biggie. You just start at the y-intercept and then you do your rise over run using your slope, your m value, and there you go. Sometimes you're given a linear function in a form that isn't y equals form. Now, first of all, is this still a linear function? Well, a linear function is an equation, check, that has two variables in it, check, and both of those variables are in first degree. That means neither of them have exponents on it, right, and check. So this is actually a linear function. It means that we could do a whole bunch of stuff with it, find points for it, we could graph it. And so in order to graph this one, we have two choices. Number one, we could rearrange the equation until it looks like y equals mx plus b, because we know what to do with that. Number two, we could find some points. And by that, I mean find some coordinates that are on the line. We need at least two. And if we actually get two that are far apart, then we only need two. I would point out that the easiest 2 points to find are the intercepts. Okay. I'm going to just show you number one here. Rearrange 3x plus 4y equals 12. We want to eventually work this out so it is in y equals form. So let's see. We'll get rid of the 3x. We'll subtract 3x from both sides. And we'll get 4y equals negative 3x plus 12. We'll have to divide everything by 4. And we'll get that y equals negative 3 over 4x plus 3. Now, in this case, this has worked out very nicely. Sometimes you'll end up with fractions. Fractions are still graphable, but if we were to graph this guy really quick, we would start by putting the y-intercept. Here it is, 3. So it belongs here at positive 3 on the y-axis. And then we need to rise negative 3. That means fall 3. We need to run 4. 1, 2, 3, 4. And there we got a point. 1, 2, 3, 4, right? And again, I like to go backwards as well. Up 3, 2, 3, and back 4. 1, 2, 3, 4. And we add our line. Something like this. Now, the second method is most often called graphing using intercepts. And all that really means is that we're going to find the x-intercept and the y-intercept, and hopefully they'll be far enough apart for us to make a decent line. And what that really means is we're filling in a little table of values, and we're going to let x be 0, and we're going to let y be 0 separately and find two coordinates. And that just means we're going to sub in x equals 0, and it would give us this equation subbed in through, of course, 3 times 0 is 0, so 4y equals 12. And y then equals 3 when I divide both sides by 4. And then I sub in y equals 0. And so I have 3x plus 4 times 0 equals 12. That, of course, goes to 0. 3x equals 12. And I divide both sides by 3, x equals 4. So when I subbed in x equals 0, right, I wanted x equal to 0, I got that y equals 3. So I'll fill in that y. Then here is 3. When I subbed in that y was 0, here it is, I get that x equals 4, and so I'll just fill in that x equals 4, right? And these two things mean, of course, that there's a coordinate 0, 3, and there's a coordinate 4, 0. It means my x-intercept is 0, 3. I'll just put that on, 0, 3, there it is. sorry, that's my y-intercept when x is 0, and my other one, my x-intercept when y is 0, will then be 4, 0. Right? You can always find an x-intercept by subbing in y equals 0. You can always find an x-intercept by subbing in y equals 0. You'll do that a lot, especially in grade 11. All right, and again, the nice thing about this particular equation is that the 2 points are far enough apart that I, get a fairly accurate line. Right? If I were to get two intercepts like this close together, I might not be able to get a very nice line with that. But hopefully, if you just check back, this line looks very much like the line that I had before. So that's it, a quick review of how to graph a line. And I would expect you, like I said, anytime in grade 10, anytime in grade 11 to be able to graph a linear function.